Welcome to the Explainer. Listen, if you've opened your utility bill lately and just kind of cringed, or maybe you've been stressing about the next big storm knocking out the neighborhood's power, you know our home energy setups have got to evolve. Today, we're diving into a massive paradigm shift. We're going to unpack the deeply complex technology inside a true hybrid command center. If you've ever wondered how modern solar and battery systems actually think, calculate, and make real-time decisions to keep your lights on and your costs down, well, you are in exactly the right place. So let's dive right in.
First things first, we've got to bust a pretty common myth. There is this huge misconception out there that a hybrid inverter is basically just a standard off-grid box with a utility grid cable slapped onto it. The assumption is that it's just dumbly passing power through from one side to the other. But as we're going to see throughout this explainer, that completely misses the big picture.
The reality actually comes down to a simple equation: measurement plus analysis plus synchronization. A true hybrid is absolutely not a dumb, one-way converter. It is an active, highly intelligent energy manager. Because home energy just isn't static anymore. This system is constantly calculating, analyzing your home's loads, and adjusting on the fly. It is literally the brains of a modern power setup, making sure every single watt is used as efficiently as possible.
So here is our roadmap for today. We're covering beyond the simple converter, inside the command center, the traffic cop of power, synchronization and grid safety, the backup reality check, and finally, managing your energy economics.
All right, part 1. Beyond the simple converter, the paradigm shift.
We really need to understand how fundamentally different these hybrid systems are from the traditional setups you might be used to. Think about a classic off-grid system. It's basically a one-way street. It is strictly linear and completely independent. Solar panels feed the battery feeds the inverter, and the inverter feeds the house loads. It really only asks one basic question: is there enough power available right now? But a hybrid system, it's a dynamic hub. It functions way more like a high-speed traffic circle. Every single energy flow, your solar, your battery, the utility grid, the backup, and your normal everyday loads, they all meet and are controlled centrally inside this one intelligent inverter. It allows energy to be routed exactly where it's needed, the very exact moment it's needed.
Section 2. Inside the command center. Anatomy of a hybrid.
So how does it actually do all of that? Let's open up the chassis. What we are really looking at here isn't just one machine. We're talking about 5 distinct, highly specialized machines engineered into a single, unified chassis. Back in the day, if you wanted all this functionality, you literally had to mount 5 massive, bulky separate boxes across your garage wall and manually wire the whole shebang together. The fact that this physical integration is now engineered into one seamless unit is a massive feat, and it's exactly what makes all that crazy dynamic routing possible.
Let's track how the power actually flows through this hardware. First, the MPPT charge controller pulls absolutely every possible ounce of raw power from the sun. That power then hits the energy manager. This is the real brain of the operation. It instantly decides, do we send this energy to the battery charger for safe DC storage, or do we push it through the DC to AC inverter, your core conversion engine, to run your television and lights? Meanwhile, you've got the grid synchronizer sitting on standby, perfectly matching utility AC parameters so it can safely pull from or push to the public grid. It is a symphony of hardware working together continuously.
Which brings us to Section 3, the traffic cop of power, system logic.
Let's talk about the exact rules that brain is executing. Unlike an older off-grid setup, the hybrid system's automatic decision-making logic is continuously trying to solve one single critical question thousands of times a second. Where should the power go right now? It has to answer this at lightning speed to ensure you never even see a flicker in your lights.
Let's look at how it answers that question with a few real-world scenarios. Picture this. It's noon on a sunny Saturday. Everyone is home and you're running the laundry. Power flows directly from your solar panels straight to your house loads. Simple, right? But what if it's 2 p.m. on a Tuesday? You're at work, the house is totally empty. The inverter senses the excess solar and automatically routes it to fill up your battery for the evening. What if the battery hits 100% and the sun is still blasting? Well, depending on your local utility rules, it dynamically exports that extra power to the grid, actually earning you credits. And if it's midnight, there is zero sun, and your battery drops too low, it instantly acts to import just the right amount of energy from the utility grid to keep your fridge running. It routes this energy dynamically, automatically, and completely without you having to lift a finger.
Let's move right into Section 4, synchronization and grid safety, the invisible risk.
Connecting to the massive public utility grid involves some seriously high stakes. You absolutely cannot just smash 2 unsynchronized AC power sources together.
it will be catastrophic. Think of it like trying to merge your car onto a busy highway at 10 miles an hour when all the other traffic is flying by at 70. It's just dangerous. The inverter has to act as the ultimate precision driver. It continuously monitors grid conditions to perfectly match the voltage, the frequency, usually 60 Hz, and the precise phase angle of the public grid. Only when those exact parameters match flawlessly will the system close its internal relays and allow a safe connection.
And that brings us to a really crucial concept: islanding. Islanding happens when a distributed generator, like your home solar and battery setup, keeps pumping power into a location even though the public grid power has completely failed. Why does this matter? Because if your inverter doesn't instantly disconnect during a blackout, it could push live electricity backward onto the public network. That would severely endanger the utility workers who are up on those poles trying to fix the dead grid. Your hybrid inverter constantly watches for this and prevents unintended islanding automatically by physically severing the connection in milliseconds.
Section 5. The Backup Reality Check, Managing Expectations. Speaking of grid failures, we really need to do a vital reality check. There is a huge assumption about what happens to a modern solar home when the grid actually goes down, and we need to clear it up right now. A very common mistake is assuming that every single electrical load in your house is magically, automatically backed up. But during a grid failure, a standard hybrid inverter does not automatically power your entire home. Instead, to save your limited battery capacity for true essentials, it isolates from the dead grid and strictly routes your solar and battery power to a dedicated emergency power supply, or EPS, output.
Here's what that looks like in reality. When the grid dies, your main panel, the one that houses your heavy hitters like the central HVAC system and your electric oven, goes completely dead. So yeah, no baking turkeys during a hurricane. But your backup, or EPS panel, that stays perfectly alive. This is where your installer wires your absolute critical circuits, your kitchen lights, your fridge, your internet router. This physical separation is so important because it ensures your expensive battery isn't drained in 10 minutes by your air conditioner right when you need emergency power the most.
Which leads us perfectly into our final section. Section 6. Managing your energy economics, taking control.
Because all this crazy hardware, all this complex logic, and all these safety features ultimately translate into one thing. The inverter is constantly analyzing your system based entirely on a priority hierarchy that you set up. You can set it to self-consumption, prioritizing your free solar directly to the home before it does anything else. You can engage time-of-use arbitrage, where you get the sheer satisfaction of legally outsmarting peak utility rates. You literally tell the inverter to charge the battery from the grid when rates are dirt cheap overnight, and then discharge it to power your home when utility rates violently spike during the evening dinner rush. You can establish a backup reserve, hard-locking, say, 30% of your battery capacity so you are never caught empty-handed in a blackout. Or, if local regulations are super strict, you can toggle on zero export, and the system will dynamically throttle your solar production to ensure you never illegally feed the public grid. The hardware is fixed, sure, but the system's behavior totally shapeshifts based on your personal financial goals.
A standard off-grid inverter simply manages raw power, but a true hybrid inverter, it is the central nervous system of a modern home. It empowers you by managing your economics through time-of-use savings. It guarantees your peace of mind and security with blackout immunity via that dedicated EPS panel, and it flawlessly handles your grid compliance through automated features like zero export and anti-islanding.
So, I want to leave you with this final thought as you look at your own energy setup. In an era of increasingly unpredictable grids and constantly rising utility costs, is your home simply consuming power, or is it actively managing its energy destiny? A true hybrid command center turns your home from a passive consumer into an intelligent, active participant in the modern energy landscape. Thank you so much for joining me for this explainer. I hope you found the engineering and economics behind all this as completely fascinating as I do.